Okay, in this video I'm going to have a look at how to use the second derivative to find inflection points and decide if a curve is concave up or concave down. So we know that when we have stationary points, that's when the derivative is equal to 0. So we've used that for quadratics and identifying where the stationary points are on that line. We're taking this a step further and we're using the second derivative to find out where the inflection points are. So when the second derivative is equal to 0, that's where the inflection points will be. So if we have a look at two types of diagrams here, we've got our pretty classic cubic and where the inflection point is, where it's coming up and then turning and going up again. Here we've got a less obvious one where we've got it changing from our concave up to concave down, and that's that inflection point there where there's that change. You can also, so that's where we can use the second derivative to determine that. So what we can do is if we find an inflection point, we can look either side of that point to see what's happening, and that can help us decide what the curve is doing. So if our second derivative is greater than 0, that means it's concave up, and if it's less than 0, it's concave down. So having a look at a little example here, we've got our function of x cubed minus x. So we can do our f dash x is going to be 3x squared, and we're taking away 1. And so then when we want to work out the second derivative, we can that will become 6x as our second derivative. So then obviously to find where that is going to be equal to 0, 0 is equal to 6x, so then x must be equal to 0. We can then sub that back into our original to find the y coordinate. So 0 cubed is 0 minus 0. So our inflection point is at 0, 0. Then we want to determine if it's concave up or concave down. So we want to sub in to that second derivative either side of 0. So -1 and 1 to sub into that rule. So 6 times -1 is -6. 6 times 1 is 6. So when we draw that diagram, we've got down, across, up. So that is our diagram that shows us concave up. So we do this test to determine the nature of that. A little bit like when we did our nature of our turning points, stationary points, we did a similar technique there. So that's what we can do with our inflection points as well. And so if we have a stationary point, that's another thing that we can use that on as well. So if we have our stationary point that's not a point of inflection, we can also tell if it's a maximum or a minimum based on the second derivative too. So that's another way that we can use that for our quadratics to determine the nature of the turning point rather than the inflection.